This is Ranjith Muralidharan. So I'm an AI researcher in Silstrat. So in today's topic, we're going to look at what is a neural styles transfer, what are its applications, and a real-time, hands-on demo on our Silstrat Hub, right? So uh, in today's session, I'm going to juggle between the PPT and the Silstrat Hub. It would be more on the hub, okay? So let me just paste the links to the chat so that you can log in. So the first link that I've pasted is our CellStrat Hub, which I'll just cover in a minute. So please go ahead and log into this link. If you have already registered, you can sign in directly. Else you can, click on this button and sign up. It hardly takes a minute. One more link, I'm going to put it in the chat. This is basically the code for today's session, right? So you can log into this. You can see a zip file, which is neural_style_transfer.zip. Just right click and download it to your system. So please start doing this. Meanwhile, I will just cover what we are seeing in the CellStrat Hub. Okay. So this is the landing page or homepage for our CellStrat Hub. You can explore more here. So this is basically like a one-stop shop where you can learn, develop, and deploy all your AI codes and stuff like that, right? And it will help you to quickly learn a lot of things. So you have a lot of expansion packs here. So let me just go ahead and sign in, right? So since I already have an account, I'm just directly going in and signing it. Else you can just sign up and so once you sign in, this will be your landing page. Okay, so here you can see once I sign in, it shows my name. You have your start workspace. So this is where we will start and deploy our all codes. So let me start my workspace. So this will take about less than a minute here to start. Now before that, let me just show you here, right? So in today's topic, it is going to be neural style transfer, right? So this is part of the computer, vision pack that we already have. Now, if you take a look at upgrade over here, just click on get packs. You can see there are, as Vivek addressed before, there are 120 plus projects that we have on our hub, right? So each one are bundled together into individual packs. So you start right from the basics till, deep learning, graph neural networks, GANs, and so on and so forth, right? So please go ahead here, get your packs. Now, the one today's session is going to be within your deep computer vision. So you can get this pack, and along with this pack, that is neural style transfer, you will have other projects also which you can explore. Now let me go back to my dashboard here. Okay, so it is still loading. So let me come back to that, right? So let's first try to understand what is a neural style transfer. Okay, so this is basically a optimization technique, all right? And what it basically does is it considers two images, right? So we call it as an input image. One is the original image that you have, and the other one here, what you see here, right? So this is a style image. Now it combines both together and gives you an output which is artistic in nature. Okay, so that is the overall purpose of style transfer. So you can see some examples of images that are there here. Okay, so in modern days, you would have, people who are so into Instagram, right? You would have noticed that you take a picture and you apply some different filters on your pictures, right? And then post it, right? So that is exactly what style transfer is all about. So you have a base image, which is your original image, and then you apply a filter. Here we call it as a content image. Okay, and then you combine it together through a convolutional network, and then you get an output, which is what you see on the right hand side here, this one. Okay, so this is what is a neural style transfer. Now, first of all, why do we even need this neural style transfer, right? So there are certain use cases that we have. So these are the most commonly used use cases, right? So the first and foremost, as you everyone know, photos and video editors, right? So whatever photo editing and video editing softwares that you see applies this concept even in your mobile phones, and it also has the real-time ability to style on the go, right? That is your first use case. Second is art, right? So you would have seen, like, Photoshops and other softwares getting used, right? So typically they apply different filters, so they help, they do all this for advertisements, all commercialized arts, right? So all these things are part of one of the use cases for neural style transfer. And then of course your gaming and virtual reality. So modern day gaming has evolved a lot, right? So you have a lot of interactive modes, 3Ds, VR, in fact, virtual reality. So all these things involve artistic styles. So the background, the texture that you see, right? So they don't just give animation, but it's more about giving that artistic flavor to your video or an image to make it even better for the audience, right? So uh, these are a couple of use cases. So now this will help you to relate. So a typical example is Instagram. Just keep that in mind, because whatever we are going to cover in the next step, right, we will just try to relate it with that so that it becomes pretty easier for us. Now let me go back to the hub. So if you look at this, I have started my workspace, and you can see that it says stop workspace, so which means it is started. Now here, just click on launch Jupyter Lab.
So those who joined recently, please create an account on CellStrat Hub. Ranjith, maybe you can send the link again. A lot of people joined after you send the link.
Okay. All right. I have just pinged the link. You can just log in here. All right. Are most people able to log into this link? And please make sure that you download this zip file. Okay. It's about, like, 500, close to 600 MB. Please download it, because this is what we are going to use for today's hands-on session. All right. Now, so I have already downloaded this file. So what you need to do is, once you download the file from your local system, you just drag and drop it over here.
Can
Right?
you
See the
also send the zip file location again, the Google Drive location for the project code?
Okay, let me share that again.
A lot of people are still joining. You'll have to make it open for all so everybody can download it.
Yes, I have shared. So if the previous drive link, if whatever I have sent is not working, just please use the latest one which I've just shared. Okay, I've enabled sharing also, so you should be able to see a page like this where you can just download it, right? So are everyone good? Shall we continue?
Yes, sir.
Yes, sir.
All right, cool. So once you download the zip file, what you can do is just drag and drop into the space over here on the left, right? So once you transfer it, it will take about 1 or 2 minutes to just load that. You see that on the left here, I have already transferred it here. It's just a drag and drop from your system. Okay. Now once you do that, just do a right click. Okay, and there is something called extract archive. So the moment you click on that, it's similar to extracting your zip folder, right? So you will get a folder here called as neural style transfer. Okay, so I hope it's pretty simple, right? Day in and day out you would have done all this. So download this file, transfer it to the hub space over here once you log in. Okay, so maybe let me just go back to the hub, right? So once you come to this space, on the left hand side, you will have something called as a start workspace. So I have already started the workspace, so that's why you see stop workspace here. So start your workspace. It will take about a minute, less than a minute for it to start. And then click on Launch Jupyter Lab. Once you click on Launch Jupyter Lab, it will go to this window where you will, on the right hand side, you will have launcher. On the left hand side, you will have, different folders and stuff like that. I mean, some of you may not have, because if you're logging into the first time, never worked on it, you might have very less folders. So nothing to worry about that. Now, after that, you download the zip file from your local system. Just drag and drop into the space over here on the left. You can see that there is a neural style underscore transfer.zip file. Just right click on this and click on extract archive.
So
Once you
you
click
don't
on,
have to extract it on your local computer. Somebody is trying to extract it on their local computer. Once you download the
okay.
zip file from Ranjith's Google Drive, you can upload it, drag and drop it directly into CellStrat Hub Explorer. You don't have to extract it on your local computer. It may give unzip error.
Yeah, and please extract it within this hub. It will be easier for you, because once you extract it in your local, you cannot transfer any folders directly. You cannot drag and drop any folders. You have to again zip it and transfer it, right? So it's a double effort. So you can just directly copy
Ran yeah, it's not extracting for somebody.
Okay.
So Karan, your user is, I'll confirm it. Please share your email, Karan. In chat, please share your email if your user is not confirmed in CellStrat Hub. I'll confirm you from backend.
Yeah. And just for everyone's interest, right? In case the right click extract archive doesn't work, for example, if you're not able to extract, what you can do is, under the launcher, you see something called as a terminal over here. Just go to terminal, okay? And then type ls. So if you can see, you have this pack over here, right? So this is basically a Linux directory kind of, correct? File system, sorry. And then what you can do is, you can do an unzip neural dot zip, okay? And just press enter, it will get extracted. Okay, so you can try it in your command line also. If the right click and extract archive doesn't work, or it is throwing some error of the something, you can also try using your terminal. Okay, you see under the launcher, you can see terminal. I hope most of you have tried that. Okay, so let me just go inside the code. So once you go inside, you will have three different folders: code 1, code 2, and code 3. So what we will be covering mostly is code 1, and code 2 and code 3, we will come back to it later. It's almost similar. This is just for, your example purpose. So
Ranjit,
now
show
let
the
me
upload
go.
button also. I think drag and drop is not working for some people. You can show the upload button at the top.
Okay. So here on the top, if you people are not able to, drag and drop, there is something called as upload files. You can see on the screen, right? So just click on that. Okay. And then you can select what you want. You can go to downloads, just select the respective zip file, and then click on upload over here. That's it. So just click on this, click on upload, and it will get uploaded. So there are two options also, right? So for upload, you have drag and drop, or this upload option, which I'm showing here. And alternatively, for unzip also, you have either right click and unzip archive, extract archive, or you can use terminal and type unzip the particular zip file. Any questions before we move on? Okay. I will take it as no. So, okay, coming back to the code. So, get into code 1. Okay, so you can find a Python notebook over here, and then you will have two different folders. One is the input file. So you just go inside and you can randomly put some images over here. And then result is what we will get as an output. So we will look into that, right? So just double click on this Python notebook. It will open on the right hand side. Okay. And just for everyone's interest, this notebook or rather this code is developed in PyTorch. So on the right hand side, since I have already selected a particular kernel, it is showing as PyTorch. So you can just click here. If you click here, there is an option to select kernel. If you click on this, by default, you will have 3 different kernels, right? Sometimes you will get no kernel to begin with, or it could be default Python 3. But since this code is developed on PyTorch, you have to select PyTorch. Okay. And if you have a TensorFlow code, you can use TensorFlow, either one. So you have an option to select your kernel over here. Okay. So just select PyTorch and click on select. That's it. So your kernel will be started, right? And now what you see here is the code, right? So let's go through that. Give me a second. Yeah, okay. So let me just cover a basic high level architecture before we sort of get into the code. Meanwhile, please ensure that you download it, put it in your hub, extract your zip file, place it so that it will be easier to start, right? Okay, so let's, before we get into the code, just look at a very high level architecture of what this style transfer is all about. So as I said, your input is basically 2 images. Okay, one is the image that we wanted to transfer the style to, which we call it as a content image. This is what you see a nice car in the highway, right? So that is the content image. Now, on top of this content image, we want to apply some sort of artistic touch, which is nothing but your style image. So this is the style image, right? So you have a content image, you have a style image. These are the
Sir,
two inputs that.
sorry to disturb you in between. Actually, I am not able to launch the Python class, sir. It's showing me an error.
Python class.
Yeah,
I don't
sir.
understand. So
The launch pad which you are now doing, sir, I am not
this
able.
one.
Yeah, yes, sir. When I am clicking on the launch Jupyter tab, it's showing me that you have to set up a new password and you have to enter some token.
Yeah, you can change your password or username, whatever.
Okay, sir.
So
So
whatever
are
it's
you logging
asking.
in? I mean, if you're logging in for the first time, or
No, sir. It happened regularly.
oh, okay. So let me do one thing. Let me give you the actual login page. Maybe my mistake. So since I have already logged in, probably I would have given you the console link. So let me just put this one up. Sorry. There you go. Just click on this. Once you click on this link, you should be able to get this page basically, where you can see a sign up and sign in. Okay. And then you
Yeah,
can,
sir.
you're able to get that. Yeah.
Yes, sir.
Good. So since I've
Thank
already
you.
logged in, I put this one, right? So maybe it is taking up my, login ID. That's why your token is not. So forget about that. Just log into this one. Okay. Sign up or sign in. Okay. So I can see that there is code 3 images only. Let's look at that. So you're able to extract that complete file. I
Yes.
have, okay. I mean, is it only for code 3 you have images? You have code 1, right? At least. Okay, I couldn't hear you, but if you have code 1, that should be fine. Are everyone able to see 3 files basically? Let me just go and show you here. So you have 3 folders basically, code 1, code 2, and code 3. I mean, it's okay if you don't have code 3 also, but at least if you have code 1, when you get into that, you should see these 3 things, 2 folders and a notebook.
Yeah, sorry. Yeah, Ranjit.
Yes.
Yeah. So what is happening when I'm extracting, like previously, it was coming, there's just one folder, that was the code 3. Inside of that, there was one more folder, images. But I just deleted and tried, unzipping again by using terminal. Now there's no folder inside of that neural style transfer. It's just an empty folder.
Oh. What about others? Are you able to get these folders basically? Or is there an issue? I can download it and share it with everyone. Okay, I can see Subhash saying yes. So maybe just, okay. Some of them yes, some of them no. All right. So I would suggest one thing, right? So just close your browser, these 2 tabs, just reopen it again, download it, and in your local system itself, just extract and see whether you have those 3 folders or not. Because you see, there is like almost close to 600 MB. So there are 3 folders that should be present inside that. What you can do is you can try using terminal, right? So you just go to the terminal as I showed now. Let me just do that again. Oops. Where did that go?
Yeah, in local, it is like all 3 folders are there.
You're able to see all 3 folders?
In local, yeah.
Okay. Then yeah, so then maybe it would not have extracted completely, right? So it's a 600 MB file. Once you unzip it, just wait for a minute. It will take
Okay.
some time, right?
Okay.
Maybe you would have logged or rather gone into that folder before even it gets extracted. That could be a reason.
Yeah, maybe. So should I close and come again? Correct? Like
Yeah.
when?
Just close it,
Okay.
come again, and once you unzip it, just wait for some time,
Okay.
right? Because it's a 600 MB file, it takes some time to extract, correct?
Yeah, got it.
Because we are extracting directly on the hub, not on local. So
Yeah.
it should take less than a minute, but just wait for a minute is what I would suggest. Okay. And again, this goes for everyone, right? So just wait for a minute, extract it, and then keep it ready. Even if you don't have code 3 or some code 2 or 3, doesn't matter. You need to have code 1 over there. So that will give you an overall end-to-end picture of what we are talking about. Okay. All right. So let me get back to, meanwhile, everyone extracts and does all this. Let me just, get back to the PPT, right? So just to give you an overall view. So just a couple of key things that you need to remember for style transfer. It is pretty, simple. At a very high level, there are 2 inputs. One is a content image, one is a style image, right? So it's pretty clear what is the difference between the 2. Now, for a content image, we typically put it through a convolution network, correct? So once you apply a CNN over content image, you will get something called as a loss, right? So we call it as a content loss because it is a content image. Same way for style image, when it passes through CNN, you will get a loss, and that we will term it as a style loss. So this is most important thing in your neural style transfer, the losses. What So these losses are what will determine the exact output of your image. So this is your generated image. So you have style image, content image. It passes through layers of networks, and then you have a content loss, and then you here from style you have a style loss. Finally, those two get added up as a total loss. This total loss is what completely generates an image one by one. Now we'll go into what is a style loss or a content loss at a very high level, right? Now, there's a lot of text here, so don't worry too much about it. So basically, let's look at a simple terminology, right? So your content loss is nothing but your distance between your input and output image, correct? So as I told you before, this is your input, this is your output, right? So whatever you're getting here, you need to make sure the loss is very minimal as possible. So here within the content loss, what we will try to do is we will ensure that the content remains intact, because you don't want the lower layers. You always want the higher levels of your network, because your image has to be as is, your content has to be as is, only a style has to be applied on top. So your content has to be as is. Then comes your style loss. Your style loss is nothing but, okay, so you have your correlation between your feature maps. So we'll come to what are these on the right hand side here, right? So for computing style loss, we have something called as a gram matrix. Okay, so by definition, it is a measure by which we capture the distribution of features over a set of feature map in a given layer. Now, in order to explain that better, just consider the image on the right hand side. Okay, how a gram matrix is calculated. Now you have a typical convolution network, okay, and the colors that you see are, you know, filters at a different layers, right? Now just unfold it, right? You have an unrolled version. So this is how a convolution network will be when you unroll it. Now what they typically do is they transpose this and multiply it with the transpose of your original unrolled version of your convolution network, right? And then what they do is just multiply each and every block, right? So if you look at this, you have green and green here, right? So you see green and green here. Same way here in the second block, you have green and blue, right? So basically, this is nothing but a correlation. So a gram matrix takes your unrolled convolution network layer, right? And then it multiplies it with the transpose of that network. So that is how a gram matrix works. Now, this is what is basically used for a style loss. Okay, the difference between that is what is used as a style loss. Okay, now the total loss is sum of the content loss plus style loss. Okay, so this is one of the very important concepts. One is content loss, one is style loss. So let me go back to, sorry, let me go back to the image, right? So any questions here? So we have an input, two inputs. We get losses from these two inputs. We then generate the total loss. That will then help you to create a image, which is a mixture of this and this. Okay, so this is at a very high level. How do you generate an artistic image? Let me go back, and if there are any questions, please do post it in the chat, or you can just unmute and talk.
Yeah, one question I have. So, you said style loss is difference between. Can you explain what is the what is style loss? What difference between is the style loss?
It's, sorry, okay, style loss you're talking about, right?
Yeah.
Oh, okay. So let me 1 second. Okay, so style loss is the correlation basically, okay, between different feature maps. So for in your convolution network, you will have a feature map, right, at each layer.
Yes.
So the correlation of that is nothing but your style loss. And how do you find that correlation? Is nothing but using your gram matrix.
So
This is,
basically, gram matrix is the style loss.
I wouldn't say gram matrix is the style loss, but it is, what do you call it? It's a measure. Gram matrix is a measure using which you will compute your style loss.
So we will subtract this gram matrix from the original image and we get the loss.
Yeah. I mean, it is not a direct subtraction per se. Okay. It is basically a multiplication of your transpose of your convolution network. If you see here, right? So you have unfolded this, assume this is your convolution network unfolded, and then you multiply it with your transpose, and you just practically see the images on the screen, right? So you have green, then you have green, blue. So it will basically, for each and every, multiplication that it does, it will compute the loss and it will give you the overall layer. Overall loss for those filters.
Okay.
Okay. So this is not a pixel level calculation. Please remember, this is a content level. So it's at a feature level. Each layer will have a feature map, correct? It will identify what is the relation between each feature map, and that is computed using your gram matrix. And this is what is a measure which will be helpful for finding out the style loss. So there is a big equation and all which is available. Now I didn't want to show that equation because you will never understand, right? So this will give you an idea. So I will also show you the equation when I go through the code. Okay, how they are calculating the content loss and style loss. Okay, but this is at a theoretical level, how it works. Any other question? All right, if not, let's quickly get into the code. So I hope everyone has downloaded this, at least the code one. So you double click on this, you will get the Jupyter notebook over there here on the right hand side. Okay, and please, if you have not selected any kernel, please go ahead and select your kernels. Okay, here in this session, this particular tutorial will be of PyTorch. Okay, so since I've already selected, I'm just gonna run it. So initially what I'm trying to do is just, run this command over here. So these are all your, import functions. Okay, so these are all these things you must be already aware of while running other projects, right? So your NumPy, Torch. So you basically import all your necessary packages that you require for your style transfer, right? And then the second, it is still running. So the second point or the second line is, I'm just trying to figure out what device I have, whether it is a CPU or a GPU, right? So some people may not have GPU, so I'm just trying to figure out whether it is a CPU or a GPU, right? So it will help me to, run the model. If it is a GPU, it will be faster, right? So that's why. Now here in the code, okay, so in line item 4, what I'm trying to do here is I'm just defining the output image size. Okay, just putting some value over here, and then I'm just transforming the image. So as I mentioned before, you have images which you will load, correct? So I'm just applying the basic transformation function to convert it into a tensor, and then I'm just defining the image loading function. Okay, because we are inputting two images. One is a style image and a content image. So you need to have some loader function, correct? And then here, this is where I'm defining it. So here I have already in my input file, I have something called as a starry night, correct? So a JPEG file, and then content image, I'm keeping it as galaxy. You can use anything that you want, right? You can just download any styles you like, any content you like, and you can just put it in this folder and just put the path over here.
You can double click the JPEG file to see how it looks.
Yeah. So let me open both, right? So this is the starry night, right? So this is your style image. Okay. And then I just click on galaxy. Okay. So this is the basic image that we have. This is your content image. And this is your style image. So what I'm planning to do is apply the style that you see over here onto this particular image and see how the output looks like. Okay. So, all right. So now here, okay. So here we are basically create, one second, let me just check. Yeah, okay. It is imported. So let me just run it right quickly. Okay. So I'm just defining the function here. I'm just inputting the image. Okay. So just bear with me. It's taking a bit of time. Okay, meanwhile, let me go to the other part, right? So I've given two images to load here. So here we're just creating a simple function here to display the loaded images Okay, nothing great and all. Okay, you can just use a pill image, or you can directly, open it and check it also. I mean, it's up to you, right? So it's just showing your image to see. So here, as I told you before, this is your style image. I'm putting just a heading here as a style image and your content image, correct? So this is what we saw there. Okay. Okay, for some reason it is still running. Not sure why, but okay. Let me go to the. All right. So I mean, this is the basic formula. Okay. So I know it's a little crazy formula here, right? So as I explained before, so this is your content class, right? So your P, your X, your L. Okay. So your original image, your generated image, and then your layer. Okay. And then it gives you 1/2 of this. So I know this is, I mean, even it's difficult for me to sit and explain all this, but I, at least at a very high level, you have understood what a content loss is, right? Basically, what we are trying to do here is we are trying to identify the difference between your original image and the generated image. Okay, that is your content loss. I want to make sure that my original image remains intact, and only thing that I'm applying onto my original image is my style image. And what will help me here is the layers. So I need to make sure that only the higher level layers are kept intact, and only the lower layers the style is applied. So in that case, I will not lose my content image. I will retain it and apply my style. So let me just see if it is okay. For some reason it is a bit slow. Give me a sec. Okay. All right, fine. So I hope everyone to do it till here, right? So if you just click on print on this, you will get 2 images. Okay. Okay, finally, yeah, it worked. So yeah, so I'm just inputting the image, and then I'm just trying to show that image. Okay. And then you have your content class. So here I am defining the content class. Okay. So this is a standard code that is available. So you need not worry about this. You can just Google and find out, okay, this is a content class function which is available. You can just directly copy paste and use it. Then comes your style loss, right? So if you look at this, this is the formula for a style loss. Where is that? Yeah, here. Okay. So whatever is n, right? It represents the distinct feature maps, and m represents the height times the width of the feature map. So by just looking at the the naming or convention here, right? Feature map. So all the style loss depends upon the correlation between the feature map. It has got nothing to do with your input image or output image. It has to do more with the feature map of those layers that are there in your convolutional network. Okay. And then finally they are applying the original loss. Okay. So overall loss, total loss function, which is nothing but, you see a formula here, but basically it is nothing but a combination of your content loss and style loss. Okay. All right. So now here we are defining the gram matrix. As I told you, gram matrix is one of the measures used for style loss, right? So you will define a function called as a gram matrix, and this is again, gram matrix is already available. It's a predefined function. Okay. Uh, Typically in some of your online notebooks and things like that, they will not define all these functions individually. You will use some sort of an API or something to directly call that function and then use it. Okay, here why I wanted to put this is so that you understand that, okay, typically each function is getting declared over here, and this is at some given point of time getting called in a later code or a line of code, right? So here you define your loss function. So 1 second, I think I ran till here, right? Let me just rerun this. Okay, now what we're planning to do is, so for for this, we are downloading a pre-trained model. So you can also train your own model using convolution network, but that is going to be time consuming. Rather, for so there is a research that has been done by certain folks, and what they have decided is to use a VGG19 model. Okay, so your core or the backbone would be a VGG19 model, and the research paper says that VGG19 model is being trained on some millions of data sets, specifically on image data set, right? And that's why they sort of already trained it. So we are directly going to use that model. Okay, and then I have already downloaded the predefined model. Okay, it will be in the form of .pth. All right, and then here what we are trying to do here is we are just defining those layers, right? So here, I'm sorry, where did I go? Yeah, okay. So here, typically your VGG5, your content layer, we are going to pick up the 4th layer, and for your style, you will have 1, 2, 3, 4, 5 different layers, right? So this is also, so if you look at a typical example of a VGG model, you will get all this. You don't need to, worry too much about this, but you can just Google VGG19. You will get to know what it is. Based on that, you can apply. So here it is pretty simple, right? So we're just, getting the layers. We are just first defining your losses to a blank value or a 0 value. And here we are just trying to do a iteration here, right? So from here to here, it is nothing but iteration. So what we are trying to do here is we are trying to pass the input data or the input images into a convolutional network, trying to compute the losses, and for each loss we are trying to okay, gram matrix is not defined, so I think I have not run some module. Okay, this module I have not run. Okay, so you have to run each and every line of code in order. Okay, otherwise if some function, if it is not defined, it will be a problem. You can see that it will throw some error. Okay,
So I am running it. I am in the last, it's training my style model, but it has 500 iterations. It's taking some time. So far 100 iterations have run.
Right. So I'll just quickly come to that.
Okay.
So anyway, let me just, so these are all, okay, content loss is not defined. So yeah, I mean, you have to run, sorry, you have to run line by line. Okay.
Those of you who are facing trouble, you should use the option kernel, restart kernel, and rerun all cells at the top. In the menu, there is a menu called kernel. You can restart kernel and run all cells. Then it's working fine for me.
Okay.
Restart kernel and run all cells, because first time I ran it, it didn't run. But when I did this, it ran fine.
Okay. Yeah. I mean, when you run it individually, sometimes you would have missed one of the, blocks, right? So I missed to run this block as I was just scrolling and explaining. So you can just click here, restart kernel, run all cells. So it will be run in order. Okay. All right. So let's just go here, right? So yeah, so I hope everyone has run till this one, and here I'm just showing. So for me, it is just showing an error because I have not run that line of code. Okay, that content loss I have not run. That's why it is showing here. So you have to just run it in order. Okay. All right. So here I'm just displaying the image, how it looks like. Okay. Then what I'm trying to do is here we are just applying an optimizer. Okay. So typically research has said that LBFGS. So it's one of the optimizers, right? So it is the best suited or best applicable optimizer for any style transfers. Okay, this is again based on research paper. The second best would be Adam optimizer. Okay, so you can either use LBFGS or you can use Adam optimizer, but LBFGS is the best because it will help you to reduce the loss as minimal as possible, because the whole agenda of your style transfer is to focus on your losses, right? And then This is the last line. I think this is the last line of, yeah. So this is the last line of code. Okay. So basically I'm just setting up 500 runs. Okay. It will increment in 50s, right? So if you just run the last line, you can see that, every 50 runs, it will compute the style loss and content loss. So the more you run, you need to ensure that the style loss and the content loss is very, very minimal. So right now, if you see at the 500th run, your style loss is like 0.4 and content loss is 3.3, right? Now, if you ask me if this is enough, it is again based on your decision, right? If you want, you can even run it further. And what will happen is, so you just take a look at this picture, right? Maybe this is a bad example of mixing two images, but it again depends upon you, right? What image you want to. So you can even take your picture as your content image, apply like a basic style and see how it works. Okay, I'll show you one more example, a very simple example here in code 2.
So Ranjit, in Facebook, sometimes, Facebook will paint our picture with the Indian colors or something.
Yes.
So possibly they could be using style transfer, right? Possibly.
Yes. No. Even Facebook is using Instagram. So Instagram typically uses this.
Okay.
Okay, but only thing is, I mean, as we are advancing, right? They have invented even more optimized techniques.
Yeah.
Though the core remains VGG, they have applied more and more filters, more and more optimizers, and made it even more fine-tuned. All that they have done. Right. So let me. All right. So can someone take a chance and show your screen and do code 2? Somebody wants to try code 2.
So while we are running code 1, we can parallelly run code 2, right?
Yes. So you can just open all the 3 if you want to also, right? And just parallelly run it. It doesn't matter. So that it takes, because always the last line of code where it applies the transfer, it takes about roughly about less than 3 minutes or 4 minutes, depending upon which tier you're in, right? So if you're in a GPU tier, it will be lightning fast. But again, if you are in a basic tier, it would take about some time. Okay, so let me just so I'll not run the code, but I want everyone to run code 2. So go inside code 2, just double click on this. Okay, so let me just quickly go through it, right? So these are all just, you're just downloading all your codes and weights and stuff like that. Nothing much to worry. So here you're importing your weights. So here, if you see in the previous example, we have used LBFGS, right? So here, if you see, I'm using Adam. So there is no much difference between the two. You can use either this or this, but this is little bit even more accurate than this. That's the only difference. It'll make sure that your losses are reduced a little further, but more or less it remains same. There's no much variation, I would say, right? And then you're defining all your pre-trained models over here. Max pool you're applying. You're checking what you have, whether it is you have CPU or a GPU, and then same like previous example. Here we are just slightly doing a different thing. So I'm just using CV2 here, but in your previous example you would have used something else. Okay. So yeah, where is that? So here, here for each and every function, I'm putting the function here so that you can go and understand what each function does. I mean, it is not really necessary, but at least you get to see what they are defining in each and every function, right? But in this, there is no function and all. I am just directly reading the image, converting the image, pre-processing the image using transfer. Okay, so that is what is happening here. I'm just converting it into a tensor, and squeezing it, and then I'm just defining a transpose function. And then finally, I'm just applying the, here I'm just loading the image, okay, and showing the image. So this is my image. This is my, this is my content image, style image. And finally, I'm applying the VGG skeleton. Okay, I'm just loading the skeleton, applying the pooling layer and things like that. This is nothing but your loss. Okay, we have seen before, right? Content loss, style loss. And then we are doing a VGG forward pass. This is again to ensure that all your, the pre-trained model, right? You have to use the relevant weights and layers, right? So that is what we're doing. And then you can see that, okay, this is your initial layer generation. This is your style. And then where is that? Okay, here you are defining the optimizer. Okay, so here I'm telling the the optimizer, you look at this, right? So if optimizer is this, you apply this, else you apply Adam is what I'm defining. So earlier I've already defined optimizer as Adam, so it will run Adam optimizer, and you can actually see this here. So I'm not able to expand this, but what it will do is during each iteration, right? It will tell you what is the style loss, what is the content loss, and it will also give you the total loss. So initially it will be a blank image, of course, and slowly as the iteration moves, right? So you can see the difference. So slowly the content image is getting generated and your style is getting applied on your content image. So you need to keep running this up to a certain number of iterations. If you want, you can try more also. And finally, I'm showing the output here. So you see this was your original image. This is your stylized image. Okay. All right, I'll just take a quick pause here for any quick questions. I'll also show something, maybe just for you to sort of research. Any questions, Steve? Anything? Okay. All right. So I hope everyone has run code.
The first one ran fine. The second one, it's asking replace readme.md, yes, no, all, none, are. Is it getting stuck there or is it moving forward?
Sorry, which one?
In the very first cell.
Okay.
Very first cell, show the output of the very first cell in code 2. Code 2,
you're talking about this one?
No, code 2.
Yeah, this is code 2.
The very output of very first cell, go down a little bit.
Okay.
Yeah, print hello world. So make directory cannot file exist. Okay, go down a little bit. Yeah. The hello word is being printed for you.
Okay, here, this one you're saying?
The hello word is being printed. So, but I am not getting similar output.
No, I mean, hello world is just, I mean, it's simply, so I just printed so that
But
it
I'm
passes
seeing some
out.
other output being generated for me.
Oh, okay. So basically, this entire code, right? So basically, we're just downloading the image and model. That's all. We're not doing anything. And why okay, maybe why you might get some error because there is already an image folder. Right? I have already, it's a zip file, whatever I've shared, already contains the image folder and model folder. So if you're again trying to run this code, it will give you error because it says that model already exists. But it's okay, it will still run. I mean, in the sense, though it will throw error, it doesn't matter because you already have your image and model folder, and within that you already have that path, the model file. So you can directly skip your first line and run the second line.
Correct. So we have to run from second cell onwards, right?
Yes, correct.
Not the first cell will give error and it will block the further code. So we should start running from second cell onwards.
Yeah. So basically, we are trying to get the model from this website. Okay, and then we are creating a directory and then copying that downloaded model to that directory. what you all can do is you can just remove these two files, I mean these two folders, and you can try again. So basically you will have only this file and I think, yeah, only this file you will have. Rest all are not required if you actually ask me. I mean, you're just downloading it and putting it into this folder, that's why. So you all can start running from the import function onwards. Even for your previous one, in case if you see that somewhere, okay, yeah, here it starts from import only, so that's okay. So even in code 2 or code 3, if you find, we are using some wget or make directory, you can just skip that because you already have downloaded it, and that is what I've shared with you. You don't need to download it from the internet again. Okay. And so I was just doing some, to find out where these models are getting used, right? So I found one app. Okay, I mean, this is again just for an example purpose. So there is something called Runway ML. Okay, it is basically a video editing software sort of a thing. Okay, I mean, I'm just showing an example. If you're interested, you can just go through it. So basically, you can in fact apply real-time images over here. You can apply an image or a video, and you can apply all these filters. Like for example, I had told you that, okay, in the first code we can use neural style as a VGG model, right? You can in fact, I mean, somewhere I've seen, okay, I mean, I'm personally not used it, but I've seen that people import a code into this particular software and they run it to see how it works. You can even switch on your web camera and apply this VGG code that you have. Okay, it will actually run in real time over here. You can just go and explore. This is something that I found. I mean, I'm not personally used it, but I just found it to be interesting while doing some YouTube research. All right. So, any questions, team? Let me just summarize before that. Okay. So basically, just a quick recap. Neural style. Okay, so it basically blends your content image to a style reference image so that the content is painted in a specific style, right? The artistic output that you get. So that is the whole purpose of your style transfer. And it basically uses a pre-trained convolutional neural network for feature extraction. And then you have two different type of inputs. One is your content image, another is your style image. Now, the basic architecture of the model computes two different losses. The losses are pretty important over here. One is the content loss. Second is the style loss. Content loss is the difference between the higher level intermediate layer feature maps. Basically, you can just say that it is nothing but the loss between your input and your output. Okay, to put it in a simpler way. And then your style loss is your difference, the amount of correlation that you identify within your feature maps in your layers, right? And finally, this is a growing topic, and where it is predominantly used is your gaming, virtual reality, photo, video editors, and so on. So this is what basically, Facebook, Instagram, everywhere you would have seen the filters and contents, right? So this is what is getting used. So always the base layer is your VGG, okay? And then on top of it, they kind of add different networks. Even your GAN model, the general adversarial network, is also getting used. I've also seen people use the GAN model over and on top of this VGG network, and they have got a very pretty good outputs, right? And advancements are also there. There is something called as a fast style transfer. So which means when you use a typical neural style in the form of a VGG, it takes about some time, right? But to eliminate the so you need output in a real time, correct? Now when you run the code and get the output, it is taking quite some time, correct? So there in fast style transfer, you will get it within seconds, mere seconds. Okay. So, all right. So that's the overall. Any questions? Anything, team?
I have one question, Ranjith. The optimizer that you used, right? LBFGS, right?
Huh.
Is it used only for the style transfer, or it's being used for other use cases?
No, you can see it's a generic optimizer. You can use it for any of your projects, right?
No, recommended. I'm wondering what's the best you
No,
think.
I've seen that one in many projects, Manimoy.
Okay.
So that LBFGS is very popular for some reason. It's a mathematical formula. So just like there's gradient descent or Adam optimizer, LBFGS is one more, and we have often seen it being used in different projects.
Okay. Okay, Vivek, I have got one suggestion. Maybe if you can take it. The thing is that this whatever uploading things, whatever downloading and uploading. Actually, I could not do it yet. Okay, because it's my maybe internet speed is very slow or whatever maybe. Okay, so is it possible to give something like a direct link from the hub itself, right? So we already support wcat command and things, right? So so that somebody gives the link and it will automatically gets from there, right?
But
So
the Git clone is supported. So if this is stored in Git, there's a Git link in the menu if you notice. So we can do a Git repo from anybody's GitHub. Yes, that can be done. So we can clone a repository. That is probably the easiest way.
yeah, because otherwise what happens downloading and uploading things, right? If it is bigger things, sometimes you cannot even.
So good suggestion. I did note that, in fact, myself as well. I just wrote to our team that, okay, actually, in Colab also we faced the same problem before. We had to upload the files into, Google Drive and mount the drive in Colab. So it wasn't any better. If there was a single notebook, it was easier, but anytime there was a folder, it was the same issue in Colab also. I think here cloning a repository looks like an easier technique for larger files. Yes.
Yeah.
So we can directly clone a repo. Yeah. If you have it in GitHub Hub, we can directly clone it. Yes. So I was able to do what Ranjith suggested during this workshop itself. So it worked for me, but it did take time to upload the zip file from my computer to this environment. Yes, it took like 5 minutes.
Yeah,
but
I still could not do it.
Yeah,
I still could not do it. That's what I'm doing. So.
Yeah. I got the point. So yeah, I was able to do it, but then once I did an extract archive, it happened in seconds. But the upload of zip file took like 5 minutes. Yes. So if your internet breaks, your zip upload will fail. Yes.
And once we extract it, what is the next step?
Just run code 1. In code 1, run the notebook file, please.
Directly. Okay. So we have to enable any of your? There are 2-3 packs, no?
No, pack is independent. This project is independent of packs. So no need to have any packs. You can check out some of the packs. Don't check out too many packs. You know what? If you check out all the packs, what will happen? You in free tier you get 8 GB of hard disk storage. It will max out your 8 GB if you check out all the packs. So make sure you only check out the packs you are really interested in. Okay. Don't check out all the packs because in free tier you only get 8 GB of persistent storage.
So you can just take a look at it here. Okay.
We can stop it also, no? If you check out it, and if you don't want it,
you can delete it. But there is a slight problem. Even if you delete it, next time you start your workspace, it will download again for you. Again, max out your space. So if you by mistake check out all the packs and your 8 GB is consumed, you can contact CellStrat. We will manually delete some of the packs from your hub account, so that it will not download them again next time you log in.
Okay.
All right, over to you, Vivek, for the final.
No, so all 3 code demos are done. You had code 1, 2, 3, right?
Yeah, code 3. I've just put it for self-learning.
Okay.
Basically, it's just a simple thing.
Okay.
Okay, so
So you can actually run this project in Colab or any other. VS Code also supports Jupyter Notebook, but there you'll have to figure it out yourself, because that is the problem CellStrat Hub is solving. That we are providing a integrated environment where project is certified to run on Hub. It may run in Colab, but you'll have to debug it there because of different runtime environment. So maybe Ranjit, because a lot of people joined later during this course of this workshop, maybe you can kind of do a quick review again, just a revision, if you will, but very fast, like 5 minutes.
on the code, right?
On the algo and the code. Fundamentally, what is happening in the algo, and maybe just the code one will be sufficient.
Okay. So let me just, yeah. So I think this should be enough for those who joined a bit late, right? One sec. Okay. Yeah. All right. So in the style transfer, basically there are a couple of key things that you need to remember. Okay. Your input will be two inputs. One is your content image. Second is your style image. Okay. So your content image is the image that you want to transfer the style to, right? And this is your style image where you have to apply this. Now, your content image and style image will go through different layers as part of your, when you apply your CNN. Okay. And from your content image, once it passes through your CNN, it gives you a loss, and that is called as a content loss. Okay. Now, from a style image, again, it passes through a set of layers as part of the CNN, and it gives you a loss, which is called as the style loss. Okay. The combination or the sum of both content and style loss gives you the total loss. And this total loss is what will determine your output image. Now, if you see an arrow which goes directly to the generated image, right? So this is what will give you your output image. And this is your content loss, style loss. Now, content loss is pretty straightforward. It is nothing but the distance between your input and your output image. Okay. But what is style loss is very important. It is the correlation between your different feature maps. So here, if you look at this, where is it? Yeah, here. Style image is there, right? So it goes via a different layer. So this is your first layer, second layer, third layer, and so on and so forth, right? So each layer will have its own feature map. Now the correlation of each feature map between one layer to another layer will give you the style loss. And how is that computed? We have a measure mechanism and it is called as gram matrix. Okay, so it's called as gram matrix. What it does is it will pick up a particular convolutional layer. It will unroll itself, and then it will be multiplied with the transpose of that same layer to get you the gram matrix. And what you get over here, this measure is what will help you to identify or compute your style loss. And total loss is nothing but sum of those two. Okay, so this is at a very high level. And then one more thing which I discussed is why do we even need this, right? So basically in your photo or video editors, you use it. Typical examples are your mobile phones and your Instagram, Facebook, all these things, right? And then your art and entertainment. So you would have seen different advertisements with some artistic touch and all, right? So those days, people go and draw those on the big hoardings and all, right? Nowadays, with the advancement of technology, they kind of do all these online, and then they print it out in a big sheet of thing, and then they put it on your advertisement hoarding. And then you will have gaming and virtual reality, right? So all your interactive whatever interactive environment that you see in the gaming, right? So it should be as clear as possible. So they also apply, so it's basically like an animation, right? So they apply that artistic touch to your image that is getting generated on the screen. It's basically a video, right? So it will help in your gaming and virtual reality. And then quickly going through the code. So I've shared the file. There is code 1, 2, and 3. In code 1, let's look at neural style IP and YP. So basically, I'll just quickly scan through the code. So initially, you're just importing all the libraries. Then I'm just identifying whether there is a CPU or a GPU. Okay. And then I'm just defining the image, transforming it, and I'm also putting a loading function, right? Now, once I have defined the load function, I'm inputting my image and I'm just checking the image style, right? And then I'm creating a function to display our images. So just this is your input image, sorry, this is your input image, content image, and your style image. I want to apply this to this, and then define content class. So this is a function to define your content class. Then we move on to style loss. Here, as I told you, before we compute style loss, before you compute style loss, you have to compute your gram matrix. That is a measure. So here in cell 10, I'm first defining gram matrix. And then here I'm defining the style loss. Then I'm downloading the pre-trained model. Okay, so here research people have used VGG 19 model because it is getting trained on millions of data sets. Okay.
No,
And
just
then,
as a research interest, Ranjit, what if I, instead of style and content images, I have two content images, let's say two of my own photos? What will it do? Probably it will try to superimpose to two of my own photos, right?
Yeah, it will try to superimpose two of your own photos, but typically your output itself will be like a, what do you call it, like a smudged image or something sometimes.
Okay.
Okay, because style, you have to define it clearly.
So one of them I have to mark as style image, the second one as the content image.
Yes, correct. Just to differentiate between the two, right?
Because the loss definition is different for both the images.
Exactly.
Okay.
So here I'm already defining, so here I'm defining style image and content image, right? You can just put whichever you want here. I've already defined it here in these two lines. So you can just replace this JPEG with your image and again with another image of yours, right? Okay, all right. So back to this one. So so I was just downloading the predefined model. Okay, and then I'm just computing the layers.
Hello.
Yes.
Sir, can I ask something?
Yes. Go ahead.
Sir, this Vision AI hands-on workshop develop neural style transfer project. Who is who are the students you are conducting this for?
No, this is a public workshop, Pratim, right? It's open to anybody, right? It's conducted by CellStrat company, which is our company.
So, sir, that's why you posted because we were doing Urvasi Vansal ma'am's class. So that is
which
probably
college are you
another
from?
workshop.
Which college are you from?
Techno Batanagar.
Yeah, we do so many workshops, right? Some of them are for specific colleges, some of them are open to public. Like this one is open to public. That's how. Okay.
Oh, okay, sir.
Okay, thanks.
Okay, all right. Okay, so quickly, right? So then we define the optimizer, okay, and then we create a number of runs and we just run the model, okay. And what you see is like it will go through different runs. You can even increase it. It will take a bit of time. So I've just minimized it to 500 because it feels easier, right? So this is how your stylized image will look like, okay. Now what you can actually do is in your code 3 there is something called MSG net, okay. You can try that. It is even faster while you run it, okay. So here they are applying some fast transfer technique, okay. It remains the same only, but they are using some fast multi-style generative network it is called. This is again a research paper. Okay, so here you can actually run it faster. Your output will be even more faster. You can try this offline. Okay. All right. So this is at a very high level. I hope it's clear. I would just take a pause for any last questions before I hand it over to Vivek.
Hello, Ranjit.
Yes.
Yeah, Manjunath here. Yeah,
Yes. Good.
I believe like we can implement this, style transfer through cycle GAN as well, right?
Yes, you can.
Yeah, is there any valid reason, it's better than, VG19 or which is better? I mean, which model is, gives minimum loss like that?
No, I mean, that is again based on trial and error, Manjunath. So even if you actually, look at cycle GAN, right?
Yeah.
Your base model is always VGG19. They are applying transformer on top of your VGG convolutional network. If you actually look at it.
Okay.
Okay, you can go through the online codes which is available, right?
Yeah.
Everywhere that you see VGG19 is what is used because it's a basic convolution network, and based on research they have identified that that is your starting point or like a backbone, I would call it, right? And on top of that you can apply whatever model you want. There is no limitation. You can even try AlexaNet also.
Okay.
The core remains similar to VGGNet. On top of that, you apply whatever models you like. I mean, you can explore it, but we cannot say that, okay, this model is better than the other one, right? It always comes with a trial and error method. For some of the things, AlexaNet would be better. Some of the things, GAN would be better, right? It could be different.
Yes, correct. Yeah. Thanks, Ranjit. Yeah.
Any other questions, audience?
Yeah, the screen where you uploaded the file. Now, how do you do that in the upload? Can you just show that?
So on the top, you have an upload option here.
Okay. Okay.
Just click on this and it'll open your, Windows.
So I upload the zip file as it is, or?
Yes.
Okay. Okay. Thank you.
And after uploading the zip file, right click on that and upload will take 5 minutes. The zip file is 700 MB, in size. So it will take 5 minutes to upload. It will show a scroll bar of upload. Once it's done, you can right click and, unzip it, extract archive.
Okay. In my Google Drive, I tried actually. There were 3 files. It was showing some error. Some 6,
3 folders it will show within the zip, basically. Is that what you're saying?
Actually, there were 110 files overall, and then 106 of them copied. So they were showing some error in some of the files. Maybe some, during upload something happened or whatever. And I was trying from my drive, Google Drive.
No, I mean, in order to avoid confusion, you upload it as a zip file and then extract.
Okay.
Why? Because I would have already run those codes, right? So there could be some images and models and stuff like that which is already there. And if you add all those up, obviously there could be some 100 files.
Okay.
Could be.
Yeah, that's okay. Thank you. I'll try.
Okay. All right.
So Ranjit, I was able to run all the 3 projects, and I did everything right during this workshop itself. So it worked fine for me. All 3 of them are running fine. Only in code 2, I had to skip the first cell because the folders were existing, and so first cell I skipped and ran from second cell onwards. But in code 1 and 2, I ran the entire notebook. It ran fine. The third one runs in few seconds only.
Few seconds, right? Yeah.
Yes.
Correct. Perfect.
This MSGNet is a different algorithm?
I mean, it's just an advanced model using the same VGGNet.
Okay.
I mean, it's a different research paper. They use the same VGGNet, but they applied multi-style into it. They say it is multi-style. But
did we see GAN also for style transfer?
I'm sorry?
Did you find in your research anywhere anybody using GAN for style transfer?
Yes, cycle GAN is being used.
Okay. Okay.
So that is what even somebody asked a question, right? So in one of the papers, like they have applied cycle GAN over and above the what do you call it, VGG network. And in fact, I also wanted to get that, but since the training or the size of that is pretty huge, okay, so I ran into some issues yesterday, so that's why I couldn't get that. But it is pretty much doable.
Okay, nice. Any other questions, audience?
Hi Vivek, Anand Muralidharan this side. Nice to meet you all after a long time. Appreciate Ranjith Muralidharan for this wonderful session. So Vivek, when we will get in-person mode? I'm waiting for that.
Anand, long time. Where are you, man? Where are you, Anand? Long time no see, huh? Okay.
A little busy with the work, Vivek.
Okay.
Catch with all. So happy to see. It's this is really a wonderful platform. Vivek is actually helping all of us. It's not the business actually. So it is a wonderful platform for the entry level, mid level, even for a senior level people to get a hang on what is the latest technologies in the AI world. So you will get the length and breadth of what is available. So please make use of it, and all the best for all the CellStrat interns who are doing with Vivek. So yeah, Vivek, happy to join.
Thanks, Anand. Thanks for those kind words. Appreciate it. We'll connect later.
Yeah.
So yeah, the in-person, every time I think of start doing a in-person meetup on a Saturday in WeWork Bangalore again, another variant comes along. So unfortunately, COVID won't let us allow us to attempt an in-person meetup again. But long looking forward to that. Yeah, it's been 2 years. So
sure.
So audience, thanks Anand. Thanks for joining. Audience, any other questions for Ranjith or about CellStrat? My name is Vivek. I am the Chief Data Scientist at CellStrat AI Lab. So feel free to ask any questions. You can also contact us offline if you want to join our internship programs.
So are you doing any projects?
We are doing countless projects. That whole platform you see, we have already 120 plus projects bundled on that platform, and several hundred more are in the pipeline. We have conducted close to 500 AI seminars / webinars in the last 4 years, which are available on our YouTube channel as well.
Are there research projects or
both R&D, right? A lot of this was advanced artificial intelligence and graph neural network, neuromorphic AI, right? Reinforcement learning, unsupervised learning. So we are state-of-the-art AI lab, yes. Okay. Contact us offline if you have any questions and if you want to join any of our programs or internship communities.
Can you tell more about the internship program?
So let's talk one-on-one to understand your background and to provide you the right fitment, right? So I'm providing my number here. Just reach out to me. Vivek Singhal is my name. And we have a large team of AI experts such as Ranjith here who help us conduct such workshops and help develop our platform CellStrat Hub as open source contributors. Any other questions, folks?
Thank you, sir.
So, all right. So, in interest of time, thanks all for joining. Thank you, Ranjith. A fantastic presentation, and look forward to your next sessions already. All right.
Yeah. Thank you, everyone.
Thank you all. Have a good day, and we'll see you in our future workshops.